Good morning, class. Can you hear me?
Yeah, Loshi, good morning.
Yeah, good morning. I can hear you.
Good morning.
Okay. Okay. Last class, we have reviewed the key points of engineering materials. And today, let's proceed to the next unit, the strengths of meshing elements. We will spend 8 hours studying this chapter. Okay.
Okay, Loshi.
Okay, teacher.
Okay. The goals for this class are as follows. We design for static strengths and the vertical and cyclic stresses. Design for cyclic loading and failure criteria and modes of mechanical failure. Okay. Okay, we know that the common failure modes in meshing elements include deformation, yielding, fracture, fatigue, and well. And this is a picture of deformation. Deformation includes elastic and plastic deformation. And this is a picture of fracture. The fracture may occur in both brighter and ductile material. And this is a picture of vertical. Vertical fracture is a sudden failure taking place due to the initiation and propagation of a microcrack under fluctuating loads over a period of time. And the loads causing vertical failure are usually very low, usually below the static failure level. Okay. And identification of possible failure modes is an essential step in the early stage of meshing element design. So we have the factor of safety. Safety is always the paramount criterion in meshing design. To provide a safe, reliable meshing element, it is essential to establish design criteria against potential failure modes. And the design criteria commonly used against the previously discussed failure modes include strength, rigidity, life, and wear criteria. First, let's say the strength criteria. Okay, and strength is the ability to resist loads. It is expressed in terms of ultimate strength sigma B and yield strength sigma S and vertical strength. The strength criteria indicates that the actual stress acting on an element at a critical location must be less than the allowable stress of material. This is the allowable stress. and the actual stress is obtained by calculation according to loading condition. And designers must ensure the maximum stresses are less than material stress limit by a sufficient margin to guarantee adequate safety for an element. And the margin is the safety factor. It can be expressed as this. The safety factor should larger than the allowable safety factor. Okay, and the allowable safety factor is generally within the range of 1.25 to 4. And the safety factor is expressed as this. We use the limit stress over the actual stress. And safety factors are employed to consider uncertainties and variabilities in loads, strengths, manufacturing qualities, and operation conditions. For rigidity criteria, we have the deflection Y should satisfy that the actual deflection Y should less than the allowable Y, and rigidity is ability to resist deformation. It ensures accurate operation of a machine. And for life criteria, the life L of an element should be longer than the expected life. And for well criteria, we have this. The pressure P between contact surface must satisfy the following criteria. And the above criteria are applicable to the case that the material bears static loads. However, the stress acting on mechanical elements is not always static stress. An example is the load acting on a pair of messenger teeth. So we should consider the cyclic stress. Cyclic stress, also called fluctuating or alternating stress. Okay. This is the classification of alternating stress, and stress can be divided into two types: cyclic stress and random stress. The cyclic stress changes periodically with time. Stable and unstable state. This is a stable cyclic stress. The variable stress will change periodically with time, and the change amplitude remains constant. This is stable cyclic stress. And this is unstable cyclic stress. The amplitude of change also changes periodically. And this random cyclic stress, the change is not periodic. Okay. For fluctuating stress, stress variations are characterized by 5 parameters: the maximum stress, the minimum stress, the mean stress, stress amplitude, and stress ratio. If any 2 of them are low, the others are readily computed. The mean stress is the average of the sum of maximum stress and minimum stress. We also have a stress range. It's a maximum stress minus minimum stress. And for the stress amplitude, it's half of the stress rate. The stress ratio is the ratio of minimum stress to the maximum stress. And the amplitude ratio can be expressed as this. Okay, this is the figure of fluctuating stress, and there is the maximum stress. This is minimum stress. Okay, this is the stress rate. The maximum stress minus the minimum stress. Okay, there is the mean stress, and this is the stress amplitude. Let's look at
Laoshi,
okay.
Laoshi, please, it's a little too fast. If you can slow down a little. I can't
Oh.
really.
Oh, too fast.
Yeah.
Too fast. Okay, okay. The five parameters for fluctuating stress: the maximum stress, the minimum stress, and mean stress. Mean stress is the average of the sum of maximum stress and minimum stress. And stress amplitude is half of the stress rate. Stress rate is defined as the difference between maximum stress and minimum stress, like this. This is the stress range, okay? And half of the stress range is the stress amplitude, sigma A. And stress ratio is the ratio of the minimum stress to the maximum stress. Okay. And then let's look at an example first. The maximum stress is 200 Newton per square centimeter, and the stress ratio R is minus 0.5. Let's determine the minimum stress, the stress amplitude, and the mean stress. We know that for the 5 parameters, if any 2 of them are low, The others are readily computed. Okay. We have low the maximum stress and the stress ratio. Okay. Let's see. The stress ratio is the minimum stress over maximum stress. So we can obtain the minimum stress use this. The stress ratio times the maximum stress. So the minimum stress is minus 100. Then we can obtain the mean stress. Mean stress is the average of the sum of maximum stress and minimum stress. So the mean stress is 50. And then the stress amplitude. Stress amplitude is half of the stress range. It's the maximum stress minus minimum stress and then over 2. So the stress amplitude is 150. Then we can draw the stress curve. This is the maximum stress, 200, and this is the minimum stress, minus 100. And this is for the mean stress, 50. And we also have the stress amplitude, 150 there. Okay. Example 2. We have looked that the maximum stress is minus 400 and the minimum stress is 100. Let's determine the stress amplitude, the mean stress, and stress ratio. Like this. Okay. We can use this to calculate the stress amplitude. Use the maximum stress minus minimum stress and then over 2. The stress amplitude must be positive. So the stress amplitude is taken as the absolute value. So stress amplitude is 250. The mean stress. Use this to calculate mean stress. The maximum stress plus minimum stress and over 2. And the mean stress is minus 150. Stress ratio is the minimum stress over the maximum stress. So it's minus 0.25. This is the stress curve of this, and this is the minimum stress. This is the maximum stress. The maximum stress is compressive stress, and the minimum stress is tensile stress. And this is the stress amplitude. This is the mean stress. Okay. That's the 4 patterns of constant amplitude cyclic stress. For static stress, the applied load is held at a constant value as you in the finger on the right. The stress is constant. This is for the static stress. And for alternating stress, there are some special cases as you in the figures below. This is the completely reversed stress. And the stress ratio R is -1. Then the minimal stress is equal to minus maximum stress, and the mean stress is 0. This is the mean stress is 0. An example of a completely reversed stress is a rotating circular shaft loaded in bending. When the stress ratio, the minimum stress over maximum stress, R is 0, the stress varies from 1 to a maximum value within each cycle. Like this, the minimal stress is 0, so the stress ratio is 0. At this time, the mean stress is equal to the stress amplitude, equal to half of the maximum stress. And the minimum stress is 0. So we call it repeated stress. When the stress ratio is 1, the stress is static stress. So there are 3 special cases for stress. When the stress ratio R is -1, we call it completely reversed stress. When R is 0, it's repeated stress. If R is 1, it's static stress. And this is a fluctuating stress. H is an alternating stress with a non-zero mean value. It can be regarded as the superposition of a completely reversed stress on a static stress. This is a fluctuating stress. Okay. For completely reversed stress, the mean stress is 0 and the stress ratio is -1. This is the amplitude ratio. The amplitude ratio is infinity. And for repeated tension, the minimal stress is 0 and the stress ratio is 0. Okay. And the mean stress is half of the maximum stress. This is for repeated tension. And for repeated compression, the maximum stress is 0, and the mean stress is half of the minimum stress. Okay. And this is an example of completely reversed stress. A rotating circular shaft loaded in bending FR. In this position shoe, the point at the bottom of the shaft experience a tensile stress. While points at the top of the shaft has the same magnitude compression stress. This is an example of repeated stress. The stress on the two surfaces of a pair of machine gears. No. And this is an example of fluctuating stress. The fluctuating stress can be regarded as the superposition of a completely reversed stress on a static stress. So when an axial load FA is applied to the rotating shaft loaded in bending FR, the shaft experiences a fluctuating stress. Now, let's do some exercises. Select the correct statement. A. Fluctuating stresses are only generated by fluctuating loads. B. Static loads cannot generate fluctuating stresses. C. Fluctuating stresses are generated by static loads. D. Either static loads or fluctuating loads can generate fluctuating stresses. So, which one have you chosen? Which one is correct? A, B,
The
C,
first
D.
one. A.
Which one?
A.
A?
Yeah.
Okay. Fluctuating stresses are only generated by fluctuating loads. Let's see this. This is a fluctuating stress, the completely reversed stress. So the load FR, the bending stress, FR is static stress. So static stress can generate fluctuating stress. So A is
C.
wrong. C?
C. Yeah.
Fluctuating stress are generated by static loads. Okay. The correct answer is D. Either static loads or fluctuating loads can generate fluctuating stresses. D is correct. Okay. D is correct.
Lassie, can you please explain why B is not correct?
Why B not correct?
Yeah.
Static loads cannot generate fluctuating stresses. We have this. The example.
Yeah.
This shaft is subject to a static load. Fr is static load, but it can generate completely reversed stress. Okay?
Okay.
The Fr is static. So B is wrong. Okay? So D is correct.
Okay.
Okay. Let's see this practice. The strength criteria can be expressed as, which is correct?
A.
A. J sigma is the actual stress
Applied
on
stress.
the element, and this is the allowable stress. So the actual stress should less
Let
than or lower than or less than the allowable stress.
yes.
Less. And this is the safety factor. When you design the element, you choose or calculate a safety factor, and this is the allowable safety factor. So this calculated safety factor should
Less than or equal to the allowable safety.
less or more than or larger than.
No, I think it's C.
C. Yes, C is
Wow.
correct.
Wow.
The actual stress acting on an element should less than the allowable stress. Okay, and the safety factor should larger than the allowable safety factor. C is correct. And both F and FA are static loads. Which of the following in figure represent the stress at point A with a stress ratio of less than -1 and less than 1? A, B, C. For A, the shaft is subject to a bending load F. Okay. So F is static load, and the stress is static stress. And for B, the shaft is rotating. The shaft is rotating, and then it's subject to a bending load F. So it's a completely reversed stress, all right? For B, it's completely reverse stress, and the stress ratio is -1. For this, A is the stress ratio because the stress is static stress, so the stress ratio is +1. And for B, the completely reversed stress, the stress ratio is -1. And for C, an axial load is applied to the rotating shaft loaded in bending, and the stress is a fluctuating stress. So the answer is C. Okay, the answer is C. For A, the stress ratio is 1. For B, the stress ratio is -1. Okay. Okay. Any problem? So the answer is C.
Okay, Loshi.
Okay. And we have learned that the minimal the mean stress is 250, and the stress ratio is 0.25. So let's determine the maximum stress, minimum stress, and the stress amplitude. Okay, let me see. This is the answer. We have low the mean stress and the stress ratio. The mean stress is the average of the sum of maximum stress and the minimum stress. And the stress ratio is the minimum stress over maximum stress. So we can calculate the maximum stress and the minimum stress and the stress amplitude like this. Okay. Any problem? Any problem?
No loss, no loss.
Okay. Let's
Yeah,
have a
Loshi.
break. Let's have a break. Okay.
Yeah, Loshi, can you go back to the formula again of this problem?
This.
Yeah.
Okay. Any problem?
Yeah, the formula, that formula of this question.
This question.
Yeah.
So you need the calculation person.
Okay, it's okay, Loshi. I will manage later. No problem. Okay, let's continue. Or let's break.
Okay. Okay. Let's have a break. Okay.
Okay, Loshi.
Okay.
So, how many minutes is this break, Loshi?
50 or 20. Okay.
Okay.
Okay.